Hello and welcome back to another video. We're looking at chapter 3.7, related rates. Here are some of the guidelines for you to how to solve these type of problems. Go ahead and take a look at those. Thank you so much for coming back, and please subscribe if you're liking this content. Like and share. So here's the problem we're looking at. Problem 24 from chapter 3.7. Trough is 12 feet long and 3 feet across the top. Its ends are isosceles triangles with altitude of 3 feet. Question number 1. If a water is being pumped into the trough at 2 cubic feet per minute, how fast is the water level rising when the depth h is 1 foot? So first of all, let's try to identify what it means by 2 cubic feet per minute. So 2 cubic feet per minute. As you can see, there's something in change of volume over the change of time. So dV dt based on the units. Now, because we have a triangle shape here that I'm highlighting, and then we have a length here of 12 feet, that will calculate the total volume for this trough. Now, the area of a triangle is simply base times height over 2. Keep in mind that the base and height are in terms of feet, both in terms of feet. Now the change in volume though is equal to simply the area of a triangle times 12, and 12 is fixed. That doesn't change. It's in terms of units of feet. Okay, so now we're ready to simplify this. So that will be base times height over 2 times 12 feet. Okay, now, and I'll simplify this furthermore. This is simply 6. I'm going to keep the actual number in front. So 6, and that will be base times height. And then, of course, this is in terms of units of feet for the 6th units that we have there. Okay, let me remove that and just keep in mind that this is in terms of feet, right? And then base as well in feet and height as well. So as you can see, the relationship, it's cubic feet already. Now we know that the base is changing and the height is changing, so we need to find a way to simplify this. So the best way to do that is by looking at similar triangles. We know that the first triangle has a base and a height, right? But it's similar to the bigger triangle, which has already a base, which is 3, and a height that is also 3 feet, right? So if we look at that relationship, then we can say that base for the small one is the same as a bigger one, which means that height of the smaller one is the same as height of the big one. So in other words, we can simplify by multiplying by 3. This crosses out 3, and then base and height are equal. So they have a relationship that they're changing at the same rate in this example. So therefore, I can change base to be the same as height. So therefore, volume is equal to, I'm going to use a different color, so that we'll have 6. And we have base, which became h times h, right? Which gives us 6h square. Don't forget the units. We have cubic feet here already, right? Those are the units, so do not get confused. All right, let's take the derivative now. So dV dt is equal to, and now we're multiplying the power times the leading coefficient here. So 6 times 2, that will be equal to 12. And then we keep an h. Now the change in height over the change in time, dH dt. Now that we have that information, question or letter A is asking for the level rising, so dHdt. So let's solve for dHdt. So let's divide by 12h and then divide that by 12h. Keep in mind the units here, okay? So 12 has units of feet, and then height has feet as well. So that's square feet. Just keep that in mind. Now we have eliminating 12h on this right hand side. So therefore we end up with dh, or the change in height over the change in time, equal to we have dv dt times, keep in mind dividing is the same as multiplying by the reciprocal, so 1 over 12h. Alright, so now that we have this here, we're ready to solve for dh dt. I can simply say equal to, all I'm doing is I'm using all the information, I'm using it and put it on the other side of that equation. So here we have the change in volume over the change in time. So that will be 2 cubic feet per minute times 1 over, and then we have 12. We need to put in a 1 there, 1 foot there. Okay, and we have the units here. Remember the 12 and the h have feet, right? So 12 has feet and 1 foot. So therefore, when we eliminate the actual units, this is 1 and 2, so eliminates 2 and you end up with feet. That's what we're looking for. So we end up with 2 over 12, and then at the top it will be feet over minute. Therefore, when we simplify this, we get 1/6 foot per minute. That is the solution. You can leave it like that, or you can simplify it. I'm not going to simplify that. It's just a fraction. Now, letter A, if the water is rising at a level of 3/8 inch per minute. So let's do the conversion to 3/8 inches per minute, right? So all we need to do is we need to change that to simply feet, right? So we need a ratio to convert that. So 1 foot has 12 inches. So therefore, we can eliminate the inches here, inches there. We end up with 3 over 8 times 12 feet per minute. And then if we simplify this furthermore, the 3 goes once, the 3 goes there. How many times? That will be 4 times, right? And this is equal to 1 over, and then we have 8 times 4 feet per minute. That's what we have so far, which it's simply simplifying it. That's equal to 1 over 32, and then foot minute. Now that we have that information, it's just a matter of plugging into our equation to find the rising rate. So dH dt, we have the formula already, and that's equal to dV dt, which is here, right? So dV dt, the change in that is 1 over 32, and that's in terms, I'm going to use a red color to determine feet per minute, just to not get lost. And that will be equals to times 1 over, and then 12 And then the height is equal to 2 there. Equal to. Therefore, we have 1 over 32 times 12 times 2. And this is feet per minute. Alright guys, that's the answer that you have so far. Thank you so much for watching. Don't forget to subscribe and like the video. Goodbye now.